So now if we move on to drawing the different structures of an atom, you are supposed to use a compass and a ruler when you're drawing the diagrams. But over here I'm trying and drawing it with free hand. For example, if I have to draw the atomic structure for, suppose I take carbon, then how do I write carbon? Carbon 12, 6. So mass number of carbon, please copy it down, is 12. Atomic number is also 12. Number of protons, atomic number is 6. Number of protons is 6. Number of neutrons is 12 minus 6, that is why it is 6. And number of electrons is also 6. So when I draw the atomic structure, you draw it with your compass. At the center, what do you have? You have the nucleus, which consists of the protons and the neutrons. How many protons are there which has to be mentioned? This is 6. Neutron is also 6. In the first orbit, you have to distribute the 6 electrons. What is the capacity of the first orbit? To hold 2 electrons. So when you draw the electrons, it is on either side of the orbit. When you take the second orbit, please do it with the compass. So out of 6 you have already drawn 2. Now you are supposed to draw 2 more. 1, 2, 3, 4. So electronic configuration is 2, 4. Clear? Now suppose I take an element like sodium, 23, 11. So can you do it, girls, now? So do it with me. Mass number is 23. Atomic number 11. Number of protons 11. Number of electrons 11. Number of neutrons 23 minus 11, that is 12. So how many electrons you have to distribute? 2. So if you draw the structure not with a pen, not with your free hand. So how many protons you have? 11. How many neutrons you have? 12. How many electrons you have to distribute? 11. So in the first shell, how many will you draw? 1, 2. Draw another orbit or shell. So out of 11, you have already drawn 2. So now you have to draw 10 more. So what is the capacity of the second orbit? 8. So 2 plus 8 makes it 10. So when you draw the third orbit, it is 1. Got it? So electronic configuration will be 2, 8, 1. So this is the valence shell. Okay, so the valence shell contains how many electrons? The outermost orbit is called the valence shell, which contains 1 electron. So the valency of metals are the number of valence electrons. So the valency of sodium will be 1. Did you understand? Okay, now I move on to calcium. So if I start for calcium, calcium 40, 20, mass number 40, atomic number 20, number of protons 20, number of electrons 20, number of neutrons will be 40 minus 20, that is 20. That means how many electrons do I have to distribute? 20. I'll explain this first. So see, in the first shell you can accommodate 2. The second shell 8. So 2 plus 8 makes it 10. So another 10. What is the capacity of the third shell? 18, as we had discussed according to the 2n square rule. But yet it will not hold more than 8 electrons due to the octet rule. So in the third shell also 8 electrons will go. So 2 plus 8, 10, 10 plus 8, 18, and 2 in the fourth shell. So this is the valence electron. So you have 2 electrons in the outermost orbit. So the valency of calcium is 2. So see, proton is 20, neutron is also 20. So in the first shell 2, in the second shell 8, in the third shell also 8. You always show the electrons in a paired form beyond the first orbit. It will always be better. And in the last shell it is 2. So electronic configuration, we write it as EC. It is 2, 8, 8, 2. So 2 electrons in the outermost orbit. So the valency of calcium is 2. Understood? Okay.